Welcome everyone. In this video, we're going to learn about one of the techniques that we're going to use to solve quadratic equations. Okay, we already learned different techniques that by using the basic algebra, by factorizing or completing the square, and in this one, we're going to focus on quadratic formula. Okay, suppose we have an equation ax square plus bx plus c equals 0. That's actually the general polynomial form. And the solution x equals minus b, that's the coefficient of x, plus or minus root b square minus 4 times the coefficient of x square times the coefficient of times the constant term divided by 2 times the coefficient of x square. Okay, so this equation is known as the quadratic formula and can be used for any polynomial equation of degree 2. Unlike the factorizing or other techniques, it always follows the same technique. You don't have to use the trial and error method. Always substitute the values of b, I, and c, and it gives the value of x straight away. Let's do some examples to see how this equation works and the power of this quadratic equation when the other techniques are not that so effective. Let's now do an example, x square minus x minus 6 equals 0. So we're going to find the solution of this equation. You already know by factorizing this can be found because the factors of this equation is x minus 3 times x plus 2, and that can be equated to 0, and the solutions are x equals 3 and x equals minus 2. Okay, so the same thing can be found using the quadratic formula as well. Okay, so let's now do the same thing using the quadratic formula. So comparing this equation with the general form, a is 1 and b is minus 1, the coefficient of x, and c is minus 6. Let's now substitute the values into this equation and find the solution of this equation. So x equals minus b is minus of minus 1, which is 1, plus or minus root b square, it's minus 1 square, 1, minus 4 times ic, a times c is minus 6, and minus 4 ac is 24. So it's 24 and divided by 2i, 2 times 1 is 2. And that's actually 1 plus or minus root 25 on 2, and that gives the two solutions as 1 plus. So the two solutions are when you substitute, when you do plus or minus, 1 plus root 25 is 5 on 2, and then other solution is 1 minus 5 on 2. So the solutions are 6 on 2 is 3, and it's minus 5 on 2. 1 minus 5 is minus 4, minus 4 on 2 is minus 2. Okay, so the solution that we got is 3 minus 2, exactly the same as we got in here. So you might be wondering, oh, what is the big deal in here? We should have done this using the factorizing. But so in some cases, the factorizing is not that easy. So you know that such kind of examples, and let's do, and in some cases there's no x-intercepts, and that questions are even harder. So though even those questions, any type of questions can be dealt using the quadratic formula. So so one such example is 2x squared plus 2x minus 5 equals 0. Okay, so factorizing is really tricky in here, but we can use the quadratic formula quite easily to find the solution of this equation. So xa equals 2 in this case, and b equals 2, and c, the constant term, is minus 5. And when we substitute those values into this quadratic formula, we'll get x equals minus b minus 2 plus or minus root b square, which is 4, minus 2ic, so minus 4ac is minus 4 times I is 2 times minus 5 divided by 2i is 4. So that's nothing but minus 2 plus or minus square root of 4 minus 4 times minus 5, 20 times 2, it's 40 divided by 4, and the solutions are 2 plus or minus root 44 on 4. So there are two solutions coming out from this one. So when you make this plus or minus, so the two solutions are 2 plus root 44 on 4 and 2 minus root 44 on 4. Okay, so these are the solutions of this quadratic function 2x squared plus 2x minus 5, which we got quite easily using the quadratic formula and could have been really hard if you're using any other technique. Okay, let's do another example, x squared minus 5x plus 9 equals 0. This, as in the previous case, this is also hard to factorize and then find the solution of this equation. But the quadratic formula is so straightforward and it follows the same process as any other quadratic function. And let's now find the solution of this one using the quadratic formula. A equals 1 and B equals minus 5 and C equals 9 by comparing this with the general quadratic expression. And the solution of this equation is x equals minus b, which is minus of minus 5, which is 5, plus or minus root b square is minus 5 square, which is 25, minus 4 times a times c on 2a is 2. So this is 5 plus or minus root 25 minus 36 on 2. Okay, so this is 5 plus or minus root minus 11 minus root minus 11 on 2. Okay, so the solution, the two solutions that we get are 5 plus root minus 11 on 2 and 5 minus root 11 on 2. We know that the root of a negative number is not a real number, so that comes out to be a complex number. And so this doesn't give us, this equation doesn't have any real solution. So that means if you're plotting the graph of this function y equals x squared minus 5x plus 9, that won't have any x-axis intercept. That doesn't really cut through the x-axis. So instead the graph goes something like that one, as you can see in here. So this simply means this function has only the complex roots, or it doesn't have a real root. Okay, so only if it has a real root, it cuts the x-axis. So the quadratic formula gives us a very simple way to solve any quadratic equation. So it works for all equations and it follows the same process no matter whether it has a real root or complex roots, and if it's hard to factorize, it doesn't take into those into account. It always follows the same process. But the downside of this is it doesn't give us any insight into the problem that you're trying to solve. That's why we always prefer you to use the completing square or the factorizing techniques, because it gives us a real feeling of what you're actually trying to do. So for example, if you're trying to sketch a graph, the turning point form can be obtained very easily with the completing square technique. That will then directly give us the vertex. The quadratic formula also helps us to draw the quadratic function, even though it doesn't give us that much insight into the problem straight away. So let's take an example, y equals x squared minus x minus 6, which we already found the solutions. And for this one, the solutions were x equals minus 3 and 2. Okay, so if you're plotting the graph, the main things we need is the x-axis intercept. Yes, in this case it says minus 3 and 2 are the x-axis intercepts. So this is minus 3 and this is 2. Those are the 2 points on the graph. And what's the other thing you need? We need the y-axis intercept. Okay, so to get the y-axis intercept, you put x equals 0. And that's when you get the y-axis intercept. So when you put x equals 0 in this one, you get y as minus 6. So that's the y-axis intercept. Let's say 0, minus 6. And this point is minus 3, plus 3, 0. And this one is minus 2, 0. Okay. So we got 3 points. And okay, so now we need the vertex as well, the turning point. How can we get that? So using these two x-intercepts, you can easily find where exactly the axis of symmetry lies. The axis of symmetry lies exactly midway between these x-axis intercepts. So that could be minus plus 0.5, because 3 and minus 2, the midpoint is here, 0.50. Okay. So this is where the axis of symmetry lies. If I'm just drawing a line like that. That's the axis of symmetry. And there's another way to find the axis of symmetry if you don't want to find the midpoint of these two x-axis in this. As another way, if you look at this equation carefully, that gives a beautiful equation to calculate the axis of symmetry, which is the axis of symmetry is x equals minus b on 2i, because you can see that x equals minus b on 2i is midway between the solutions. Okay. And even if you're using that one, minus b is minus of minus 1, which is 1, and 2i is 2 times x squared, which is 2, and that's 0.5. Okay, so once we get the axis of symmetry, the turning point lies exactly on the so once I get the axis of symmetry, the vertex lies exactly on the axis of symmetry. So when you substitute x equals 0.5 into this equation, you get the turning point. So y equals 0.5 square minus 0.5 minus 6. So that will give us the y coordinate of the turning point, and x coordinate is 0.5, and that will be minus 6.25. So the turning point is located here, so which is 0.5 is the x coordinate of the vertex and minus 6.25. Okay, so now we've got the enough points to draw the quadratic function. We got the x-axis intercepts from the solution of this equation, and we got the y-axis intercept by substituting x equals 0 into that equation, and we got the turning point by finding the axis of symmetry, which gave us the x coordinate of the vertex, and y coordinate can be obtained by substituting this value of x into this equation. Now it's all about plotting this graph by going through all the points that we found. In summary, this is the quadratic formula and can be used to solve quadratic equations. And this method works, this formula works for all the equations and always follows the same process. This can be used to plot the graph if you can find the x-intercept, and you can find the y-intercept and the axis of symmetry using this equation, x equals minus b on 2i. So do as many examples as you can before we move to the other topics. Okay.